Okie doke. What do we have over here? We got a light aircraft, and it has a weight of 500 kilonewtons now. Right, there's quite a few things happening here, so maybe we'll just draw one thing at a time. So here we have an aircraft. I'm just gonna draw this as a single point, just to simplify the problem. And we also have this moving at a constant speed. So v equals to 900 kilometers per hour. Just say this is constant. Now, it's important to note that it's constant here because what does this mean? This means that your acceleration is 0. And this plays into this plays a big part in Newton's second law when we get to it later on. So over here, what do we have? 500 kilonewtons down, so this is the weight of the aircraft. So we're going to draw a force away from the aircraft, going down. This is 500 kilonewtons. Now, okay, so we can work with kilonewtons all the way through for forces, but just for the sake of working in SI units, maybe we'll just convert this back into newtons first. So this is 500,000 newtons. And we also have a thrust produced by the engines to go 12,000 newtons to the east. Okay. 12,000 newtons. Alright, what are the values of the lift force due to the wings and the drag force against the plane? Now, to figure these out, first of all, what is a lift force? Well, this over here just pretty much means how much force does it take to make sure that the aircraft stays up. So this over here can be your F lift or FL. And the drag force against the plane is really just, you can think of it as the air resistance that opposes the direction of motion. Now, if we are going in this direction, so a constant velocity of 900 kilometers per hour, it towards the right. Sorry, not towards the right. I think they say to the east in this question. So we can draw our compass over here just to say that, just to clarify what all of this means. So north, east, south, and west. And we also have drag force that opposes the direction of motion, similar to how friction works, in the opposite direction. So F friction, the frictional force. Actually, sorry, they call this drag in this case. So you just call it FD. Okay. Now, a couple of important things to keep in mind. Now, if this aircraft is moving east, and let's say it's moving horizontally completely, that means in the horizontal direction, so horizontal components, that what am I saying? So first of all, if we're talking about horizontal, it's moving constantly at this velocity of 900 kilometers per hour. So this means our acceleration in the horizontal direction is 0. So recall that the net force is equal to mass times acceleration. However, this is all equal to 0 because acceleration is 0. That means all we need to figure out is what the drag force here is in relation to the thrust force. So if you sum up all of your forces, you treat right as positive and up as positive. You can say that we have 12,000 minus FD. The drag force is moving opposite direction. This is all equal to MA, which is 0. And of course, solving for the drag force over here means that your drag force, FD, is just equal to 12,000 newtons. Okay, and the vertical scenario is very similar because this plane is we're going to assume isn't going to be wobbling all around like this. It's going to be traveling in a straight line. So what this means is that in the vertical, we also have an acceleration equal to 0. So vertical, the vertical acceleration equal to 0. So just make a note here. Assume plane is not diving or not flying up and down. It's traveling in a straight line. A straight line that is parallel to the ground. So over here, we can say that the sum of our forces is equal to ma again, but of course, if a is equal to 0 over here, means all of this turns into 0. Now, the forces that were given were an upward lift force, so Fl minus its weight. If we refer back to the diagram over here, that was 500,000 newtons, and that's going downward. So this means that this weight is minus 500,000 newtons. It's equal to 0 on the right hand side over here. So similar to what we did for the horizontal components, we know that our lift force is actually equal to 500,000 newtons.